Alright, so today is day 163 in our class. Today we're going to talk about this thing called standard deviation, and it's a bit conceptual. It's a little hard, so you have to listen through the process of what I'm talking to you about. There's going to be one calculation you need to know how to do, but really I want you to know the concept, because that's even more important than the actual calculation, because the calculation you could get a calculator to do it for you at the end, but I want you to know how it's done. So, standard deviation, it talks about normal, okay? So, looking in this room, okay, and at school in total, in this room, let's look at our heights, and I want you to talk to your group and tell each other, does your group have a normal height compared to the rest of the class, and are there any people that are abnormal, and let's not call them out, but let's just say yes or no, that's it, okay? Let's go. I think I'm almost 6 feet. I don't think I'm 6 feet, but I'm almost 6 feet. But I'm not 5'11". I'm just I'm in that weird zone. Okay? And actually, yeah, that's a good idea. Let's all stand and let's start comparing, looking around. Think about what normal is in our class. The word is normal, and is there anyone that's abnormal? You might want to walk around and go back to back to see if someone is taller. Figure out who the tallest person is. That's what I want to know. Who's the tallest person? Wow. Who's the tallest person in here? What about what normal is? Everyone's walking around. Who's the tallest?
I'm taller than Matt.
30 more seconds, walk around. I see a couple of taller people. Who are the tallest?
I think Danny's
did you figure out what a normal height was? Kind of, just by your mind. Okay, now think about the tallest person in here. Who's the tallest person and who wants to volunteer to be the tallest person?
Danny.
No, that's incorrect. He's not the tallest. Who's the tallest? Boy or girl?
It's Matt. It's Matt.
Matt? Are you the tallest? Okay, so Matt's the tallest, okay? So, I'm talking about normal now. Now, Matt's a good guy. He's a good kid, okay? He's just tall, okay? So, I'm prefacing that because he's a great student. I love having him in my class. So, but is he abnormally tall compared to the class?
Yes.
Why? Turn to your neighbors and tell them why.
Oh, Mr. Ring, she blew the roof out this.
What?
She blew the roof out this.
What did she say?
Tell us, Carly. She said, what if we are abnormally short? Carly's smart.
Could be. Okay. If you can hear me, clap twice. Thank you. So, we're thinking about if people are abnormally tall right now, okay? And we talked about Matt, okay? So, we'll keep that in the back of our brains, okay? Of course, Matt's a great guy, great human, great friend, great student. You know, he has a special characteristic. He's the tallest person in here, and some people might assume that's abnormal, okay? Today I'm going to talk to you about how do we figure out what's mathematically normal, okay? That's how we use this thing called standard deviation to figure out what's mathematically normal. Okay, y'all follow me so far? Yeah. So, we might make an assumption. Now let's just say I take the shortest student in here, whoever it is.
Daddy.
No. We're not going to call people out, okay?
Sandra.
Ooh. Or any of you, really. Listen, any of you in here. Let's say I take just one of you out and I say, you know what, I'm going to send you to Gladstone to be a math mentor for all the kindergarten kids. You're going to be a kindergarten student assignment, okay? Well, your height, will you be abnormally tall there?
Yeah, like 6 inches.
No, I'm talking about the kindergarten kids.
It's a giant. 325.
Okay, listen. You would be abnormally tall there, right?
Yeah. Yeah.
Yep, that's correct. Okay. All right, so we're talking about standard deviation, and we're thinking about everyone. Okay, so are you normally tall or abnormal? Okay. One of the concepts we need to remember from yesterday. Remember how we made a line that was from the smallest to the largest. Remember doing a line from smallest to largest. Remember how I line you all up and take you from smallest to largest. Remember doing that?
Yeah.
How many % of people are on this whole line?
16.
Now, how many % of people were on this whole line?
100.
That's what I said.
You know what? So, how many % of people are on this whole line again?
100%.
Good, 100%. Excellent. Okay, that's the concept I want you to think about, okay? So, now, let's say I wanted to, oh, by the way, these are the steps. If you're on the video, pause the video and write these down. This is how we figure out standard deviation. Okay, here we go. So you should have written that down. Okay, so let's just say, let me switch the story up. Let's not talk about human heights, but let's talk about dog heights, okay? Let's just say that these are a set of dogs. Now, I want you to think about two different words here. I'm going to put up two words that are part of math and statistics. One's called sample and one's called population. Think about that for just 10 seconds. What do you think the difference are between the two? Just thinking right now. Silent thinking. Okay, turn your group. What's the difference between the sample and population? You're going to talk to your group. What do you think the difference are? Okay, back to Mr. Rink. Here we go. So a sample is like, think about a sample when you go to Yogurtland. You're not going to, when you say, I want a sample, you're going to get a little cup and you're going to get just a little bit of the whole thing that they have to offer. You might go like, oh, I want to try this new flavor, whatever it is, and you get a sample of it. You're not going to be able to get all of the yogurt that they have available. That's the whole population. So every yogurt that they have available, all of it would be the whole population. Or for example, the total population of the U.S. is 350 million, okay? Something really large like that, right? If I were to just, let's say I wanted to just pick a few people from the U.S. and I conveniently picked all of you, would you be a population or a sample? Sample. Okay, you're just a little sample. Good, okay? So, back to my dogs here, okay? This is an example of the heights of dogs, okay? Let's say I want to figure out what's normal. We're thinking, the big question today is what is normal? Okay, we have dog heights here. Dog heights. A bunch of dogs and their heights, all right? I'm thinking, what is normal? Okay, so I'm going to start by making some assumptions. I want you to all think of a dog, stare at a dog that you would pick, okay? And I'm going to pick the dog too, and I want you to think, is it normal or not normal? Is the height normal or not normal?
Not normal.
Okay, good, that's it. Back to me. Now I'm going to pick a height. I'm going to pick this dog. I'm going to pick this gray dog right here. This is my favorite one for today, okay? I love dogs. Good girl. Handshake.
Are you sure it's a girl?
So, this dog is my favorite dog, and I'm looking at it, and I know that these are the heights because they're given in the problem. We got these various heights here. And this last gray dog is my favorite dog, and it's 430 centimeters tall. And I'm noticing that, 430, it's kind of in the middle, right? Remember how we said mean, median, and mode, right? If I were to line these dogs from smallest to largest, this gray dog would stand exactly in the middle. Wouldn't you agree?
Yeah.
Yeah, so it's got to be the normal height, right? So, and I can even prove it to you with an average, right? So let's take an average of all these. Let's all pull out your calculators on your iPads. Are all charged, so pull out your iPads, calculators. Can you do the average with your group really quick? 30 seconds. Okay, good. So our average here is 394, and in math we write an average or a mean. We put X with a bar over it. This is a mean, okay? 394. So back to my discussion here. I'm proving to you, did you notice that my dog is the closest to the mean? See how this is 430? This is only 36 numbers away or centimeters away from the average. The other ones, this Boston Terrier is 94 centimeters away. This poor little dog is not even a dog. It doesn't even have legs, okay? So, and this dog said, just put it in a bun and eat it, okay?
What the heck?
You're not like waiting.
Calm down, okay?
You said it's not a dog because it doesn't have legs.
Yeah.
That's like saying if you don't have legs, you're not a king.
Hey,
That's
you live in that's not what you live in.
that's what you said.
Okay, well, then if you take it that way, I take it back.
Dogs are humans.
Fair enough. Okay, good. I learned, it's okay.
Dog's depressing it.
It's okay.
Just don't say that for the rest of your life.
Don't do that.
Yeah, don't do that.
Don't do it. Then we're gonna think something's wrong with you.
I think you already do. It's okay. No. Okay, I think here.
I've already accepted.
So this greyhound is a lot, almost 100 centimeters taller than my average, and then this Rottweiler is obscenely huge. Look at it, even looks huge, right? So my gray dog is the most normal. It is a normal size. Everything else is not normal. Okay. That's my argument. Okay. Now I'm going to show you how to prove whether something is normal or not. Okay. So I want to give you an idea. If I were to take the whole population of all the dogs in the U.S., how many are there?
A lot.
A lot, right? I think some people own like one dog, some people own like 2 dogs, some people own more than 2. Like,
I am too.
so I think that there's probably about 200 million dogs in all of the U.S., okay? And let's just say I was able to line them up from smallest to greatest. I could figure out mathematically what the average is and where most of the dogs are, okay? So would you agree if I lined up all my dogs in order, there would be 100% of dogs?
Yes.
Okay, cool. And what percent do you think the average would be? 50. Good. Okay. So what's the average of my dogs in this example? No. What's the average? What do we say? Good. The average height is 394. Does that make sense?
Yes.
Okay. Good. So that's 50%. All right. So now we're going to start calculating the standard deviation of the dogs, okay? So I need you to write this down. Let's start by writing down the mean on your papers. This is your only example we're going to do because it takes a lot of time to talk about it. So let's start with this. And can you also write down all of the heights for me so you have it in your, your notebooks, okay? So please write down what's highlighted here. You don't have to draw the dogs. I actually don't need you to do that. So step 1 we've done already. It says identify the mean of the numbers. We just did that. Step 2, for each number, subtract the mean and square the results. So we have 2 parts in step 2. We got to subtract the mean. So here we go. We're going to start with the big dog. What's the size of the big dog?
600.
And it says we have to subtract the mean. Here we go. What's the mean on this example? So we're going to subtract 394. So write this down with me. 600 minus 394, and you all should have your calculators out handy right now. Okay?
Yep.
Okay? Everyone, even Tom needs to have his calculator out, okay? What's the second part of step 2? And then what? Then what? What does it say on step 2?
And square the result.
Oh, okay, so what's 206 squared?
42,000.
Thank you for having your calculator out and calculating that. 42,436. Good job, Matt. Well done. Okay? That's the Rottweiler. Now let's go to the next dog, which is the Greyhound. What's the size of the Greyhound or the second dog up there? 470. Good. Okay, what is the mean again?
394.
Good, so write this down. This is what you would have to do on your homework. Okay? And you just need to know how to calculate it. There are calculators that do this for you. So, okay, so now, what is 470 minus 394? What?
76.
Okay, 76 squared is?
5,700.
Good. Next one. What's the size of the wiener dog? 170 subtract 394. What is it?
-224.
Okay. Dylan and Alexis, you're on warning, or you're staying up to class. Actually, you got 2 minutes. Can you please write this down and start doing it? You're just talking over there. Okay, and then we're gonna square it. What is this? What is this squared? What's 170 minus 394 squared?
50,170.
Good, thank you. Okay. Next, what's the size? Or then we have the gray poodle. I don't know what dog that is.
Call it Bichon.
Is it a Bichon? Okay, cool. That's fine. So what's the size of it?
430,
Subtract 394.
36,
Okay, square it.
1,236.
296. Good. Last one. What's the size of the Boston Terrier?
-94.
Nope. 300. Subtract the mean, which is negative 94. Square it. Okay, cool. I'm going to stop here for a moment. I'm going to have you make sure you have all of these down, okay? This is the big calculation we have to do on this example. Okay, so we've done steps 1 and 2. Step 3. What does step 3 say? Nice and loud. Then what? Okay, so now we need to get the mean of these numbers. So all of these numbers that are highlighted. So okay, can we get the mean of these numbers? How do you get the mean of these 5 numbers, everyone? What would you do?
Add them all up, divide by 5.
Okay, cool. So let's let's all add them up. Okay, let's add these up. What do you get when you add them up? That's why we're using a calculator. It's a big number. Emily needs to do this with us, not just stare. You need to, no, you get your calculator. You're adding all these up right now. Everyone needs to participate in adding. Jaren, where are your notes? Okay, good, thanks. Okay, what's that? Okay, what's the sum again, Matt?
21,700.
Oh, that's the mean, right? Okay.
Yeah. So
Okay.
108,500.
Okay, cool. So that's the mean. Last step, step 4. What do we do with the mean at the end?
Take the square root.
Okay, what's the square root of 21,704?
Oh, geez. 471.
Nope. The square root, not squaring. Square root? It's actually 147.32. Okay, can you do that again? Again, take the square root. It's a little sign that looks like a V with a line over it. Okay.
Oh, that one.
Okay, this is called our standard deviation, okay? And standard deviation, it looks like this little circle with a little line over it. That's the symbol for math for standard deviation, okay? Sometimes they write SD in a report, or sometimes they put S. This is the mathematical symbol for standard deviation. It looks like a circle with a line over it, okay? Okay, nonetheless, we want to know what the constant means. This gives us an idea of what normal is, okay? Alright, so there's the constant. All eyes up here, iPads down, pencils down, and phones down, face down, everything clicked off and face down. Okay, this concept is important. Again, what's the average of all my dogs?
394.
Okay, good. So that is average. That's purely like in the middle, right? 50% of dogs are at 394, right? If I lined them all up, and the middle dog would be 394. Would you all agree with that?
Yes.
If we took an average? Okay, good. This gives us an idea. So what this does, it says the middle dog is 394, and if I add our standard deviation, let's say it's 394 plus our standard deviation, we would get 541.322. And if I take 394 and subtract the standard deviation, I would get 246.678, okay? And this gives us a range of what normal is, okay? This gives us a range of what normal is, okay? So, looking at your dogs, remember the dog you picked at the beginning. Does your dog that you picked part of this mathematically normal range, okay? Yes or no? True neighbors. Is the dog you picked normal or not normal? No, from the beginning. Remember how you picked one at the beginning? Okay, so Remember how I said all the other dogs were not normal? Now let's look at this Rottweiler. 600. Is 600 within the normal range?
God, no.
Okay. What about the Greyhounds?
Yeah.
Yeah, that is, right? And I said that it was really far from the mean, but even though it's far from the mean, it's still part of a normal range. What about the little wiener dog?
No.
No, it's not, right? That one is not normal. It's a smaller dog when we compare him to the rest of the population. What about the gray dog that I liked?
Yes.
Yes.
Okay, good. That is normal. I was right. And what about the Boston Terrier that I said was not normal?
Yeah.
It's normal.
Good. It is normal. Okay. Good. Okay. So that's standard deviation. Now I'm going to extend the concepts to the standard deviation chart. So you're going to see this. Don't freak out. But I'm going to preface it with this. What did that whole line represent? How many percent does the whole line represent?
100.
Okay. Think about that. Okay. Okay. Here's the standard deviation chart. Okay. You see this line that's in the middle here or on the bottom? How many percent does that whole line represent?
100.
Okay, good. All right. What do you think the middle line represents? Good. That means if I line all the people up from smallest to greatest, they'll be 100% and the middle person is 50, okay? Or, in this case, what's my example that we were working on? Dog heights, right? Okay? If I line all the dogs up from the smallest to largest, 100% of them would be up there and the middle dog would be, or the average would be 50%, okay? Here we go. So, the average was 394, right? What was our standard deviation that we calculated? 100 and what?
47.
Good, 147. So what's 394 plus 147? I would just write that down here, 541, and then I add 147 again, 688, and I could add 147 again. It's 835. And notice the middle is the average. The middle is the average. One standard deviation is 147. Then we have two standard deviations at 688, three standard deviations at 835, okay?
Huge dog.
Yeah, and we have dogs, like those Great Danes that are big. We'll talk about that in a moment. Ready? 394 minus the standard deviation we calculated is 247, and then we subtract 147 again, that's 100, okay? Okay, so remember 394 is average. Remember my dog was 400, okay? 430. Is 430 part of the average range? Yeah, it falls in here. Now notice how it falls in this like little box here. This is saying that any dogs that are in this range, there are 34% of dogs that fall in this range. Does that make sense? The whole thing is 100%. So 30% of all the dogs that I put in a row are going to fall into this range. Does that make sense so far? Okay, so let's talk about the Rottweiler. What size was the Rottweiler?
600.
600, right? So it's like right in the middle here, right? It falls in this bracket, right? There are going to be 13.5% of dogs that are going to fall from 541 to 688, right? Are there a lot of dogs like the Rottweiler? No, not a lot, but are there a few?
Yes.
No, there's still 13%. That's still pretty good, right? Think about it. How many dogs in the U.S.? A lot.
200.
200 million, right? Let's just estimate 200 million, right? So there are a lot of dogs, a lot of Rottweilers?
Yeah.
Yeah, kind of, right? Let's keep going here. What about like a Great Dane? Let's say I had a Great Dane that measured 900. It was all the way at the end here. Anyone have a Great Dane or know someone has a Great Dane, a really tall dog? Okay? I know there's one in campus, someone owns it. How many percent of dogs in the U.S. are in this category?
0.13.
Good. Is that even 1%? No, less than 1%, right? So are there a lot of Great Danes? No. So is a Great Dane a normal dog or abnormal? Good. Y'all following me right now? Good, okay. Or that little tiny dog in our example? Sure, it's 130 centimeters. So it would fall in this section here, right? 170. Okay, still, it would fall in this section. Is it part of the? Is it Is it a big population of little dogs or is it a smaller population? Smaller. Is it the smallest population? No. Does that make sense so far? Okay, let me apply it to you now. Let's just say that we were talking, remember how I talked to you about heights? Who was the person that we said was a little taller, or the tallest person in here? Matt, okay. And did some of you say that he was not normally tall? Even though he's an excellent student, great person, great friend. Everyone likes Matt, right? Right? But is he normally sized in regards to his height in our class? Yes or no?
No.
No. Okay, good. So I'm gonna prove you wrong, okay? I'm gonna tell you that he is normally sized. Ready? So let's just say that the normal size in our class was 66. This was the average size. 5 foot 6 inches is the average size student in our class, okay? That's the average right in the middle, okay? And our standard deviation, let's say I calculated it again. Let's say our standard deviation I said was 10, okay? So 66 plus 10 is 76. Plus 10 again is 86, and then we got 96, right? These are inches, by the way. And I could go the other way, too, subtracting 10, okay? Okay, think about your height, okay? Are you a normal height?
Yeah.
Are you a normal height? Think about your height. In inches. So if you're like if you're 4 feet tall, what's 4 times 12? 48, good. Okay. Or if you're 5 feet tall, how many inches is that? 60. Okay. If you're 5.5 feet tall, you're 66 inches. Okay. So turn to your neighbors. Tell them, are you a normal height or abnormal?
5'11" is 61, right?
5'11" is going to be 60 plus 11, which is
71. I got math.
good. So are you a normal height?
Non-normal. 34.
Okay. So remember, how many percent of students is on this whole line? How many percent? 100. Okay. So let's talk about your heights. Let's talk about Matt's height. How tall are you, Matt?
Almost 6 foot.
So how many inches is 6 feet, everyone? 72. Okay, 72 inches. So he's over here. He's in this bracket right here. I got a question for you. Is he normally height, or does he have a normal height?
Yes.
Yeah. You see how standard deviation mathematically proves if you're normal or not? Does that make sense, everyone?
Yes.
Okay, good. And we can use this for anything, right? Even like the shortest person in here. What do you think? Let's say the shortest person in here was like 4.5 feet, okay? How many inches is 4.5 feet? 54 inches, okay? Now, 54 inches is like a little bit off here, right? It's right in this bracket, right? Is that, if the shortest student is in here, they're not necessarily far from being abnormal, but they're in a separate category. Does that make sense? Okay? Now, I don't think the shortest person is that short. How short is the shortest person? Taller? 4'11"? Okay, good. So that's going to be 59 inches. The shortest person is 59 inches. So, yep. So still, the shortest person in here is still a normal height. So when someone, like, if you feel bad that you're like, oh, I'm too tall or I'm too short, you're really not. You are very normal, okay? Okay, so that's the lesson for today. Standard deviation. It's all about normal, okay? You need to know how to read this chart. I'm going to give you this chart for your homework. And I'm also going to ask you to remember how we calculated this dog thing, okay? That concludes the lesson for today.